This is note card number 4, which is on limits and asymptotes. These are both things that we've talked about. We talked about limits in the previous note card, and then we have seen asymptotes in both Algebra 2 and pre-calculus. So let me just say that if we think of a rational function, something that looks like this, you guys have seen both horizontal asymptotes, which are horizontal lines that as we go to infinity, we approach the function. This blue function is approaching the orange line, but it never reaches it, so that's a horizontal asymptote. And then vertical asymptotes are sort of similar, but they're vertical. So as we approach a value, maybe x equals 1, the function approaches infinity, or it approaches negative infinity, but it never actually crosses that green line. So those are horizontal and vertical asymptotes. You can go ahead and read through some of the definitions there, but if you understand vertical asymptotes and horizontal asymptotes, I'm just going to move down to the questions. So it says, for 1 through 4 below, graph and or use the table on your calculator to find the limit as x approaches infinity, b, the limit as x approaches negative infinity, and then state the equations of any horizontal asymptotes and vertical asymptotes. So before we get into too many details, A and B are really talking about what happens to the function as we go way to the right or way to the left. So for instance, there are really 3 cases. So if our function is going up to infinity as it goes off the right hand side of the graph, so as x is approaching infinity, if our function is going up to positive infinity, then we would say that the limit as x is going to positive infinity is infinity. The second case is if the function is going to negative infinity. And then we would say as x goes to positive infinity, our function is diving down to negative infinity, so we just make that negative infinity. And then the third case is the horizontal asymptote case. So the other option is that a function might approach some value. So as we go toward infinity, maybe we're approaching y equals 3 or y equals 2. And so if that's the case, our value is going to be, let's say, y equals 3. So find the limit as x approaches infinity. Looks like it's approaching 3. So that's the idea with A and B, is we're just saying, where is it going? Where's the graph going as we approach either positive infinity, so off the right-hand side, or negative infinity as we go off the left-hand side. All right, so let's look at a couple examples. Number 1, we've got a cubic over another cubic, and what's probably the most important when we're thinking about finding the limit to infinity or the limit to negative infinity is all of the terms other than the highest power aren't going to matter. So the 4x, the negative 9x squared, the 24x, and the 6x squared are not going to matter when we think about the limit to positive infinity. And that's because as our numbers get bigger and bigger and bigger, when they're cubed, they're going to dominate the expression. So these are going to end up dominating the value as x approaches infinity. And so for that reason, we can just simplify it to 2x cubed over negative 3x cubed. And what you'll notice is those cancel out and we're left with negative 2/3. So that is the limit as we approach positive infinity. As we approach negative infinity, we're going to be putting a negative number in for x cubed, and that's going to give us a negative number, but we're going to get a negative number on the top and negative infinity to the third power on the bottom is negative. So the x cubes are still going to cancel out, and we're just going to look at the coefficient. So our answer for A is negative 2/3. Our answer for B is also negative 2/3. Our answer for C, which is the horizontal asymptote, is, the horizontal asymptote is y equals negative 2/3. And then D, the vertical asymptote, we're going to have to go back to the beginning here, and we can't see vertical asymptotes unless we factor the bottom. And to make sure they're not holes, we've got to factor the top as well. So basically we have to factor this expression. And when we factor that, we get x times 2x minus 1 times x minus 4 over negative 3x times x plus 2 times x minus 4. Notice x minus 4's go away, the x's cancel out as well, and we're left with 2x minus 1 over x plus 2. The one on the bottom is the vertical asymptote, so the vertical asymptote we can say is that x equals negative 2. Alright, in number 2 we're going to take a similar approach. For the first two, we're going to assume that these terms do not matter. And so on the top we just have the square root of 4x squared, which is 2x over 4x. And so as we approach positive infinity, we're going to get 1/2. So the answer to A is 1/2. The answer to B is going to be slightly different. The reason for that is as we plug negative numbers, so in B we're going toward negative infinity. So as we plug negative numbers into the x squared, they're going to become positive, because a negative times a negative is a positive. And so on the top, all the numbers are going to be positive. Even though we're plugging negative numbers in, since we're squaring them and then taking the square root, they're going to come out as positive. Whereas on the bottom, we're not squaring and taking a square root. So those negative numbers, as we approach negative infinity, are going to stay negative. And so the answer for B is still going to be 1/2, but it's going to be negative 1/2, because that number on the bottom is going to be negative. And if you don't understand that, we can talk about that idea more in class. You can also graph this and see that that's true. That's what's happening. C, there is a horizontal asymptote, but it's different as we go to positive infinity and as we go to negative infinity. So there are really two vertical asymptotes, horizontal asymptotes. Y equals 1/2 and y equals negative 1/2. And then D, the vertical asymptote, if you just factor 4x minus 6, what's going to make the bottom equal to 0? Well, 6/4, or if we reduce that, we get 3/2. So x equals 3/2. Alright, moving on to number 3. Now we have a situation where our power is bigger on the bottom, and so as our numbers go to infinity and to negative infinity, the number on the bottom is going to dominate. It's going to be way, way, way bigger than the number on the top. And so when you have a small number, let's use 1 as an example, 1's pretty small, over a really big number, it's really close to 0, and as that bottom number approaches infinity, our number overall, our value overall, is going to approach 0. So the answer to A is 0. The answer to B is 0. The answer to C is y equals 0. And if you graph that, you're going to see what's happening there. We should be approaching infinity we should be approaching 0 as we approach positive and negative infinity. And then D, the vertical asymptotes, you're going to get from solving this equation, setting 8x cubed plus 1 equal to 0. And so we get 8x cubed equals negative 1. And moving on from that, we get 8x cubed equals negative 1/8. And if you take the cube root of that, So x equals the negative 1/8 to the 1/3 power. That gives us the cube root of 8 is 2, and so the cube root of 1/8 is 1/2, and the cube root of negative 1/8 therefore is negative 1/2. Negative 1/2 times negative 1/2 times negative 1/2 is 1/8, negative 1/8. So our answer to D is negative 1/2. X equals negative 1/2. Alright, and then last, number 4. We've got f of x equals ln of x plus 2 over 6 to the power of x. And this is where we need to think about which function is bigger. Which function is going to dominate as x goes to infinity. And 6 to the power of x is going to dominate. As it's an exponential function, it's going to get really big as x gets big, or as x goes to infinity. And so on the top, or sorry, for a, as we go to infinity, our answer is going to be the number on bottom is way bigger, and so the overall value of this is going to approach 0. B. This one does not exist, and that's because we can't put a negative number into ln of x. The domain of ln of x is it only works when x is greater than 0, so as we approach negative infinity, this function isn't going to have any value. And so for B, you can just say it does not exist. So we'll say does not exist. C, we are approaching 0 as we go to infinity, so there's a horizontal asymptote at y equals 0. And then last for D, we really have to think about what value makes the denominator equal to 0. Does anything make 6 to the power of x equal to 0? And if you think about the graph of 6 to the power of x, it looks like this. It never hits 0. It gets really close to 0 as we approach negative infinity, but it never equals 0. So we're never going to get a value of 0 on the bottom of this function. And for that reason, there are no vertical asymptotes. So we can say no vertical asymptotes. And that is note card number 4.